Today's episode is on digital twin for pain management, specifically on fentanyl transdermal therapy. I'm Flora Barhami, your host today. I'm a chemical engineer and biomedical engineer. I'm at my second year PhD at Empa and University of Bern. I worked with multiphysics modeling on different parts of human body and drug delivery as well. Something about me that I really love read, 2 truths and 1 lie. I had 2 pets. My cakes are tasty, and I really like to learn new languages. What is the problem in pain management, specifically chronic pain management? It's persistence. So it's not that the pain comes for a short time and goes away. The pain stays for a long time, and the severity of pain is so high. We cannot expect the patient to tolerate this pain. So far, we don't have a good measuring system to measure the intensity of the pain. The treatment for this issue is usually long, and the pain itself and the patient is heterogeneous. So we cannot have only one treatment for all type of pain for all patients. And that's the main issue that motivates us to have a digital twin for pain management. For this issue, we try to have diversity in our digital twin. We try to distinguish people from some physiological features that they have, like age, gender, weight, height, metabolic rate, body fat, liver enzyme activity, glomerular filtration, and blood volume. To consider this diversity, we used MCMC method, Markov chain Monte Carlo, and we used already existent package mix AK in R. But what is Markov chain Monte Carlo? Based on the literature and the knowledge we have a distribution for each feature we consider in the model. But because we only try to consider a small group of people, not the whole population, we have a sample data, which shows if the patient has this sort of age for this disease, probably the gender of the patient would be this, or the weight of patient would be this. So we have a period distribution based on previous knowledge. We have a likelihood, which is based on the sample data. And Markov chain Monte Carlo try to join these 2 distribution and have a posterior distribution. And at the end, based on this result of this posterior distribution, we would have our second population that would be the population we would work with. After diversing people based on these physiological features, we would build a digital twin for each one of them. Our digital twin has 3 main parts. First part is drug uptake model that includes transdermal patch and the skin layers, and drug from transdermal patch goes through the skin to reach the blood circulation. After reaching blood circulation, we have the pharmacokinetics model. In the pharmacokinetics model, drug would be distributed through the body, metabolized by liver, filtrated by kidneys, and at each time step, by using this model, we would have the concentration of the drug in plasma. Based on the concentration of the drug in plasma, we would have pharmacodynamics model. In pharmacodynamics model, we will evaluate the effect of the drug on the patient. This effect can be favorable effects like pain relief in this case, or some adverse effect, nausea, headaches, or one of the main adverse effect of fentanyl that it is the main purpose of this study is reduction in ventilation of air or breathing pattern for the patient, which in severe cases might reach to death of the patient. So for using this, developing this digital twin, I used PD and OD in COMSOL, which briefly I show now. This is a simple geometry that I consider, not for model for digital twin, but for explaining. You can go to in physics of the COMSOL, use mathematics based on your model. You can choose that you work with PD or OD. In my system for the drug object model, I have PD, and for the pharmacodynamic and pharmacokinetics, I had OD because I consider the system well mixed. You can choose, for example, ODE, and if this equation needs to be solved on the domain, on the boundary, or on the edge, you can choose the main physics for yourself. For example, I choose boundary here. Then here you can choose which domain you want to have or which domain you don't want to have. For example, we can choose these two domains we don't want. And here, if you go to the distributed OD, you see there how the equation looks like. Based on your physics that you are trying to solve, you might have both of these used both form derivative in this format, or you might just remove one of them by putting the coefficient 0. And based on the knowledge that you have for the system you are solving, you can assign different values for this a coefficient to solve your physics for your problem. So I get back to the slide. And in summary, I generated a population of patients to consider inter-individual variability. For this purpose, I use MCMC in R. For considering the diffusion process of drug from patch to the skin, I use fixed second law, which I use PD interface in COMSOL. Then at the end, I had pharmacokinetics and pharmacodynamics in my model, which I use OD interface in COMSOL. The highlights of this episode that digital twin can be helpful for healthcare. Implementing inter-individual variability is possible by doing some statistical modeling in advance and combine the result with your physics-based modeling. And using equation-based modeling in COMSOL can help you to do more than the module that we have already in COMSOL. And at the end, I want to say that if any of you is interested to be a part of Multiphysics Channel, you can contact Donato Rubinetti at Empa if you want to present about COMSOL, ANSYS, Python, or any other topics that you find it interesting. Thank you so much. If you have any question, I'm here.